Hello, Thor. Can you hear me? I can, can you say something?
Good morning.
Good morning. Sounds good. Yes, I can hear you. I trust you can hear me as well. So, how is life? The eruption has stopped, but it seems it's coming back. Today is January the 5th, and there is new activity going on the Reykjans, as far as I understand. What's your take on that?
Well, the current situation is such that the seismicity is fairly low. Let me just turn this off real quick. So seismicity is in the Svartsengi and Grindavik area, it has tapered down. There's still a little bit of sort of less than 1 magnitude earthquakes that happen there along the Sundhnúkar lineament. What that might mean, when maybe there is some magma moving down there, or just maybe the fault is just settling. We don't really know which one it is. We also have continued inflation or rise of the land in Svartsengi.
Yes.
It's continuing at a slightly slower pace now, and it was after the end of last eruption. So basically the land began, when the last eruption ended on the 21st of December, the Svartsengi started to inflate again.
Right.
And it's been rising constantly since. So clear sort of the more straightforward interpretation of that is that magma has been delivered from the deeper storage zone, somewhere between 10 and 15 kilometers, and from there into a shallower storage zone at 4 to 5 kilometers, like we had before the 18th of December eruption, and also before the events on the 10th of November. So basically what we're seeing now is kind of a repeat. We have this inflation, it reaches some sort of a peak, and it seems to be very close to the peak now. It seems to be very close to or at the level of as it was before the 18th of December.
Right. So, yeah.
It's already started to slow down a bit, which to me sort of is indicating that you are probably filling that storage zone, and you're stretching the overlying rocks or the walls of that storage zone, and they are sort of at their limit of stretching. You've been stretching and bending them all the time while you're pumping magma in there, and now you sort of reach the stage where the pressure is high, the force you put on the wall or the roof is also high, and you're stretching that, and you've already stretched it to the almost its limit. So it's going to fail in the near future. I mean, maybe today, maybe tomorrow, maybe the day after. I mean, I think it's a matter of days rather than.
So you think it's a matter of days until it ruptures and leads to another, presumably relatively small eruption, similar to the one we had just before Christmas?
Yes, I think it would be, the sequence of event would be probably similar, and this could lead to an eruption. But if it leads to an eruption, it's going to be quite a small eruption. The 18th to 21 of December eruption probably is not much in terms of magma volume. It's probably not much more than 4 to 6 million cubic meters. I mean, the bulk volume that people have been reporting is about 11.
Right.
This is mostly shelly pahoehoe. And there's a lot of shelly pahoehoe, proportionally, because it's such a small lava flow field. It is closest to the vents. Shelly Pahoehoe has void spaces up to 80%.
Absolutely, exactly. So there's a lot of empty space in there.
There's a lot of empty space that, you know, especially in the vicinity of the vents, which is basically a 3.5 kilometer long line, or even 4 kilometer long line, where you have all these craters. And so the Shelly Pahoehoe proportionally takes up actually a significant area of the total lava flow field. And so maybe the average porosity of this is on the order of 50%.
Yes, I see.
So that's hence the number, like right around maybe 5-6 million cubic meters is the total volume.
Yes, the dense rock equivalent is that's exactly the issue. Yeah.
Magma erupted. Which, you know, compare that to Celtic Italia 2021, it's 1/20th of that volume, and that was not a very big eruption. It's half of what came up in Little Rutor and the 22 Neanderthal eruption.
Yes, because I heard some colleagues say just before the Christmas eruption, or just before the Christmas eruption, that this might be a big eruption, and I was very skeptical about that. And it turned out to be a very short and a very small eruption. And of course, the issue is not the size; the issue is the proximity to infrastructure and to settlements like Grindavik.
Yes, and the other issue is that a lot of people, and including scientists, confuse the term size and intensity.
Yes, that's exactly it. Yes, I agree with you.
These are not the same thing. This was, in the beginning, was a very intense eruption. It actually came out probably very early on. It picked up a discharge on the 50 to 100, and then that gradually increased over the next hour as the fissure lengthened up to its full length. And it may have peaked after an hour eruption at right around 350, 400 cubic meters per second. And after that, it just dropped.
Exactly. I mean, it was very intense in terms of output rate at the beginning, but that was bigger than in the previous eruptions in the area, as far as I understand. But that's not the key issue here.
No. This in the beginning, this is the most intense eruption that we've seen.
Yes, exactly.
The intensity was high in the beginning, but because the volume in the storage zone is so small, and you had this high intensity in the beginning, you had high output rates with high lava fountains and all that stuff. You're emptying, or you're taking out that volume which is available for eruption out very quickly, and hence the eruption drops, and within sort of 6 hours, you actually drop down below 100 cubic meters per second, maybe closer to 50 cubic meters per second. And then for the remainder of the eruption, basically on the first day, after the first day, the eruption rate, or the output rate, is less than 10 cubic meters. And it just kept on tapering off until in the end, it was just trickling up.
It was indeed, and I was just about packing my bags and things. And, by the time I was ready, so it was over.
So, and I expect the next one to be similar. It might not be have the same initial intensity. It might be slightly less intense, because you may not build up to exactly the same pressurization of the system, and it might be a little bit more open now and easier to bring the magma up to the surface. But if that's the case, then it must start slightly slower than the previous one, and then last a little bit longer. But then
maybe yes. So, but you're pretty confident that there will be an eruption coming, another little one in the next short while.
I think that is the most likely scenario.
Yeah.
Of course, we can't rule out the possibility that magma that actually might start moving when the roof of the walls of the storage zone fail, it might never reach the surface. it might stand up on a sublime dike, or
Of course, we can't be 100% sure ever, but the probability game is the most likely scenario, as you pointed out, and this is our business really kind of dealing with probabilities.
And it's going to erupt in a similar place. And the other thing what is very interesting when you look at the way they use the INSAR and the GPS to map sort of the form and the shape and the extent of that storage zone. So that's a modeled result, and which is, as good as it is. But and the way they place it is onto Svartsengi, but the northeastern end of it is close to Stora Skógsfell, where the main crater is.
Okay.
And it doesn't quite reach that far east, but it's really close by. And when that eruption on the 18th, when it actually started at Vents, just east of Stora Skógsfell, or sort of southeast of Stora Skógsfell. And that's where you have the highest lava fountain, the most intense output of magma.
I see, okay.
And those lava fountains were about 100 and up to 150 meters high.
I see. Okay, wow. So now
quite intense, and that's where it started. And it basically means it's coming more or less straight up. And then it started growing first to the south a little bit, and then it grew in length to the north, and then it continued to grow to the south. It's almost like you had a tube like this, sort of a short fissure with a lot of magma coming up. And as it came up, it just fanned out.
Right.
Because the activity was always most intense on that particular event when it started, and it also ended there.
I see. Okay, that's interesting. Very interesting.
I think what we're seeing is something coming up like this, and then just fanning out to either direction at a very shallow level in the.
So it's more of a point source that just creates a crack at the surface, and then it fills the crack because the magma is there.
Yeah, it resembles a point source because it's a very short fissure.
Very good, very good.
So maybe a fissure which is not much more than 100 meters, 150 meters long.
Yes. Now, the crucial question just at the end is what's the likelihood of Grindavik or the Svartsengi power plant or the Blue Lagoon being affected by a recurrent eruption now?
Well, I think we've reduced the risk of that significantly, and we are continue reducing that risk by raising protective walls around Grindavik.
Yes.
So these are not walls to stop the lava flow. These are walls that actually are intended to divert it away from these infrastructure and into other pathways that can be sacrificed because they don't really have any important infrastructure on them. And hopefully, like for Grindavik, we can divert this, both to the east and west of town, and then into the ocean.
Yes.
So that's the idea, and these walls are designed by engineers using their knowledge and the newest technology in terms of how you build these kind of walls. But excuse me. But it has to be said, we think they will work, but we really don't know whether they will.
Yes, this is always the problem, and exactly. A lot of people ask about this, and of course, if the lava is very runny, then these barriers are good for diverting the flow. But if the lava is very viscous, like we've seen it, for example, in the La Palma eruption, then digging ditches or small barriers will not do very much. So, but in this case, I think the diversion sounds very sensible. Particularly, there's this older flow that goes to the east of Grindavik, and that might be an area where the flow could be diverted into, and that would then not cause a lot of infrastructural damage to the town itself.
Absolutely, and these are fairly low viscosity lavas. Well, number one,
yes,
but also, and this is something that we need to start doing here is do analog experiments, and really sort of using miniature lava flows to actually test different, tight designs and protections and stuff like that. We need to invest in that kind of a research.
That's an interesting point you make, actually. Yes, that's yeah, when I was a younger researcher, I did some analog experiments, all sorts of things with jelly and sand and things like that. And I grew out of this, but actually I think this is there may be a revival of this type of thing, because then people
we can use real lava material. We can actually imitate, these eruptions, these diffuse eruptions, reasonably accurately and fairly easily, and we can build miniature, protections or diversions, and we can test different designs, different shapes, and different material. Figure out what will work best, so we can actually, number one, be prepared for the next event when we're going to need maybe some of this stuff. Have the material ready, not be working like madmen, 24/7 like they did this time around, because that was needed, building this wall in as short of a time as possible. It's a major accomplishment what was achieved there. You build a 4-kilometer long wall in 4 weeks from scratch,
which is impressive. But of course, the point is that it's not the length of the wall, it's the design and the actual position that will be crucial here. And from that point of view, yeah.
And having some more knowledge about what
absolutely
is the best design, and have tested some of these things, and maybe be able to use some of these eruptions to also test designs.
So yeah,
promoting preventive measures. That's what we need to do. We have to get out of this responsive mode into preventive mode.
I think this is crucial, that we actually start to be proactive rather than reactive, and this is one of the key issues here. We need to think about these things in advance and have different scenarios ready. And this is where we as a society haven't quite pushed beyond what we should. We are still very reactive, and particularly when it comes to volcanoes, and this is not ideal. I think this is the future, really, to think about events beforehand and have plans ready. Let me
absolutely. No, just to that, and this is the, as much as I praise the Icelandic authorities and Icelanders in general for how good they are in reacting to situations,
but it's still reacting, and
they're dismal when it comes to be proactive and preventing.
This is, I think, where we scientists have to push harder, that we are bringing this forward and then bringing this also to the authorities, and then hopefully it can be implemented. But towards the end of our little chat, let me put you on the spot, literally speaking. Where do you think is the most likely spot of the next eruption? Where do you think it will come up? And I will not hold it against you if you're 5 meters off, but I know you're pretty good at that. So.
Yeah, my gut feeling tells me that it's probably going to be very close to where it came up last time. I think that is that pathway is already established, and with just seeing how much output was through that pathway in the beginning of the last eruption, that means that it is a reasonably big pathway. I mean, it's not 4 kilometers long, but it could be a couple of 100 meters long, and maybe 5-10 meters wide or something like that. Yes. So clearly you can funnel a fair bit of magma up through that. That also means that there's magma in it now, left over from the last eruption, which hasn't quite cooled down. It's cooling down, but if the time until next eruption is only a few days away, then this is still going to be
this is
fairly
still liquid. Yes, absolutely. I mean,
and that's the easiest path there. I
right.
mean, the longer it drags on, you know, if the next eruption is in a month or a couple of months, then that magma which is in that conduit or pathway that it took up in the 18th of December eruption, and that's going to start to stiff. And when it gets into the viscous state between the liquids and the solids temperatures, then it is going to be very, very strong. That's going to be, you know, much stronger than the surrounding rock. So
I think so.
Magma will not come up. Then it won't come up that pathway. We'll find another pathway, and then we have you know, a guessing game. Is it going to come up along the side of it, or is it going to find a totally new one? It could then, in my view, maybe go even west and come up in Ellsworth.
Oh, I was thinking that it might go along the lineament and actually go to the northeast a little bit further into the center of the peninsula.
But there's no way we can.
Yeah, I guess. I was hoping that this might be the case also because there's nobody living there apart from some, you know, sheep.
But if it comes up, if we have an eruption in the next few days, I think it's going to be quite similar to what we saw on the 18th of December, and it's going to be in a very similar place.
Okay, well, thank you very much for your insight, Thor, and let's see what happens. We'll all follow the kind of, you know, the life cams and things like that. So I'm curious, and well, personally, I would prefer a summer eruption because it's very cold in Iceland right now. But let's see about that. So
yeah. Well, the good thing is this is not that high up, but yeah.
Yes, that's right, and it's close to infrastructure as well.
I would not complain about an eruption in the summer and no eruption until then.
I liked the summer eruptions this year and the previous year. They were really nice, actually. So sorry. I mean, I know nature is not listening to my desires, but yeah, anyway. Okay, so thank you very much. All the very best. Bye-bye, and talk again very, very soon.
Bye-bye.